Okay, this is lesson number 4, part 3. This is adding and subtracting vectors using algebraic methods. So for this one, if you watch the previous example, I did a lot of explanation. This one I'm going to show what you require, minimum what you require here. So we are doing the resultant equals u minus v. So basically I'm just going to set it up where I want to take vector u, I'm going to subtract vector v, and that's going to give me my resultant. So now it's just a matter of filling it in. So remember from before, I said any vector can be written algebraically by taking its magnitude, which is just the hypotenuse in all these cases, cos theta I, plus the magnitude of the vector, again, just your hypotenuse, sine theta j. So we're just using that general vector equation. So that means that vector u, and this is where you got to be careful, this is my origin. I went negative on the x-axis, so it will be negative 8 cos 70 I, and then I'm going to go up, which means I'm positive on the y-axis, so plus 8 sine 70j. The second vector v, I am positive on the x-axis, so 15 cos 10i, and I am positive on my y-axis, so 15 sine 10j. There we go. Now we can just add our x components, or our I values. So I'm going to just plug that into the calculator. Negative 8 cos 70 minus, just be careful, don't forget that's what we're doing in this question, is subtracting 15 cos 10, and I get negative 17.5 roughly, 5 I. On the other side, 8 sine 70 minus again 15 sine 10. And I get a positive 4.9j. So again, I know because of this negative sign, it's going to be facing west. And I know this is a positive, so I know it's going to be heading upward or north. So my final resultant is going to, and I'm just doing this in my head, here's the origin. So my resultant is going to look like this. It's in that quadrant right there, 17.5 here, 4.9 there. So that's just to help visualize what you ended up with. So the magnitude of my resultant then, just using your Pythagorean theorem, negative 17.5 squared plus 4.9 squared. When I plug that in, my calculator tells me, hopefully it doesn't lie to me, I get about 18.2, and it's meters. The angle, tan inverse, it's always your y component, 4.9 over the x component. Again, I'm just putting positive values in because I already have my directions. I already know it's west and north, so I'm avoiding the cast rule. I just want to know what the angle is with the x-axis. So I'm just going to calculate shift tan 4.9 divided by 17.5. And I get 15.6 for my angle. So therefore, my resultant is 18.2 meters. My direction, west, 15.6 degrees, north. So I already knew, I could have filled almost all that information in based on this line right here. So as soon as I have this line, I know the direction. I know it's west and north, so I can fill out that part of my therefore statement. Now it's just filling in the numbers, so it's just figuring out magnitude and the angle related to it. So hopefully that makes sense. Be careful. Common error for people that are doing this the first time. If you've taken a physics course, you might have seen this already. Common error is your negatives on the x and y axis, so just be very careful when you're determining the sign of the component. At the end of the day, I'm looking for process, so even if you make that little mistake, it's not the difference between a 4 and a 1 or something like that. Just a little bit of a mark there because it is important, but just keep in mind if you're not getting the right answer, just check your signs because that's normally where the error will be.